Hello, everybody. Welcome to section 1.6. This section is on complex numbers. So to start off, what is a complex number? Well, a complex number is a number of the form a plus bi, where I is equal to the square root of -1. All right? Oh, and a and b are real numbers. So when we look at a complex number like this, we say that this a part here, this is the real part because there's no I attached. And this right here is the imaginary part because there is an I there. Okay? Some examples of complex numbers might be something like 3 plus 2i, like that's a complex number. It can even be like the square root of 5 minus I, maybe. It could just be like 3i, so like an entirely imaginary number. And so these are like some common forms that you'll see. You might notice that if we let b equal 0, we can have like just a real number like 2. Real numbers are like a small part of complex numbers, where just the imaginary part is 0, but don't worry too much about that. So when we're dealing with complex numbers, there's a couple operations that we can do. So operations. So first, for example, say we want to like add or subtract complex numbers. So if we have something like 2 plus 3i and then minus, let's do like 5 minus 8i. How do we do this? So we have 2 plus 3i, and what I'm going to do is I'm going to distribute this negative inside the parentheses here like that. So then this becomes minus 5, and then minus 8i is plus 8i. And then simplifying, we have 2 minus 5, and then we're going to group these two terms together. So we're going to get plus 3i plus 8i, right? And so then 2 minus 5 is -3, and then what we can do is we do plus 3 and plus 8. So 8 plus 3 is 11. So it becomes 11i, right? Cool. So pretty straightforward. What if we wanted to do something like -9 minus 5i, and then what if we were going to do times another complex number like 3 plus 2i? So how do we do something like this? Well, you actually have already developed the skill to multiply complex numbers together, because you can just distribute them like polynomials. So this -9 goes to those two, and then let's do that right there, like that. And so when we distribute this out, we have -9 times 3 for this first one. And for the second red line, we get plus -9 times 2i. And for this first blue line, we get plus, so then we got -5i times 3. And then for this last blue line here, we get plus -5i times 2i. Okay, cool. And then if we do some simplification here, we get -27 and then minus 18i, right? So this -9 times this 2, and then minus 15i plus, and here's where it gets a little tricky, because we've got this -5 times 2, so that's going to be not plus, minus 10, and then we've got this I times this I, so then we have I squared. All right, but now here's the thing about I squared. Remember that I is equal to the square root of -1. So if we square both sides, we get I squared equals square root of -1 squared. which will just pop out to be -1. So now that we have that rule, what we're going to do is we're going to replace this I squared with -1. So we'll have -27, and then we can combine these two together, and that'll form -33i. And then this becomes -10 times -1, so +10. And so once we simplify, we get -17 minus 33i. Cool. So now, the last kind of thing that we're going to be doing with complex numbers is dividing them. So it's important to know how to do that. So let's say we wanted to do, let's say 3 plus 2i and then divide by 4 minus I, right? And so the best way to do this is by making this denominator real. And so first, what we're going to do is find the complex conjugate. Complex conjugate looks like this. So if you have a real number, an imaginary number, a plus bi, the complex conjugate of that is a minus bi, right? So in this case, we have 4 minus I, and so this becomes 4 minus I, which is 4 plus I. And so then once we have that complex conjugate, what we're going to do is we're going to do 3 plus 2i over 4 minus I. We're going to multiply it by 4 plus I, top and bottom, like that, our fancy one. So I'm not changing anything. And the reason we're doing this is because when you multiply a complex number by its complex conjugate, something interesting happens. And we'll see that here. So if we leave just 3 plus 2i, and then this becomes 4 plus I over 4 minus I, 4 plus I. And then we can distribute this bottom one like that. And you get 3 plus 2i times 4 plus I on the top still. And on the bottom, you get 8 plus 4i minus 4i minus I squared. You're like, oh, would you look at that? These 4 i's cancel out. And according to our rule here, this minus I squared becomes, you guessed it, positive 1. 3 plus 2i, 4 plus I. So this becomes 8. And so if we know that I squared equals -1, negative I squared equals -1, which is just positive 1. So this is 8 plus 1. And so I'm going to go ahead and distribute these as well now, like that. And so we'll get 12 plus 3i plus 8i plus 2i squared all over 9. And then if we combine like terms on the top, we get, so remember, if I squared is -1, then 2i squared is going to be 2 times -1, which is -2. So this is going to be 12 minus 2 plus, and 3 plus 8i is going to be 11i all over 9. And then we get 10 plus 11i over 9. What I'm going to do is I'm going to split this fraction up. I'm going to do 10 over 9 plus 11 over 9i. And so this is a complete way to write the division, in the sense that like this is a complete answer. Whenever you want to simplify a complex number, you really want to get it in this a plus bi form, right? Because we could have in theory just like left it this way, but complex numbers are much easier to deal with if they are in this form right here. Okay? All right, that's actually all for complex numbers. Pretty short lecture today. Keep working on the homework, and I'll see you in office hours.